Welcome to the MKN universe. The aircraft you are looking at is the Sukhoi Su-57, known to NATO as the Felon. This airframe represents Russia's first operational entry into the fifth-generation stealth multi-role fighter category. The airframe's design integrates structural stealth, a 360-degree sensor network, and super-maneuverable propulsion. To understand how it functions in a combat environment, we have to look past the titanium and composite exterior and examine how these independent subsystems are physically wired together. Achieving fifth-generation performance requires the physical synthesis of invisibility, situational awareness, and kinetic agility. This technical infographic outlines the aircraft's baseline specifications. The Su-57's primary design objective is to minimize its visual, radar, and infrared signatures without compromising aerodynamic lift. The structural foundation relies heavily on advanced composites like polymers and fiberglass built over load-bearing aluminum honeycomb. These composites make up roughly 25% of the aircraft's empty weight, but cover over 70%. To solve this, engineers designed the air intakes with a serpentine or S-shaped curve. Straight radar waves enter the intake, but bounce against the ram-lined inner walls, dissipating before they can ever reach the spinning turbine blades. The next major vulnerability is payload. Hanging missiles and bombs on external pylons creates immediate radar spikes, breaking the aircraft's stealth profile. Looking back at the schematic, you can see how Sukhoi addressed this. The Su-57 utilizes 4 internal weapons bays, 2 large tandem bays in the main fuselage, and 2 smaller side bays near the wing roots, ensuring weapons are completely shielded during combat approaches. The resulting airframe is a strict engineering compromise. Every angle and internal compartment is calculated to maximize radar signature reduction while retaining enough structural integrity and lift to perform as an air superiority fighter. Conventional fighter jets typically rely on a single, forward-facing radar cone housed in the nose radome. The Su-57 discards that approach. This profile diagram details the SH-121 multifunctional integrated radio-electronic system. The primary AASA X-band radar in the nose is augmented by 2 side-looking cheek arrays located just behind the radome. By combining the forward X-band with these side-looking arrays, the pilot's angular targeting coverage drastically expands, creating a nearly 360-degree field of view. Returning to the diagram, sensors embedded in the leading-edge root extensions house L-band radar arrays. Operating on longer wavelengths, these detect stealth-optimized airframes. At the canopy front sits the 101KS electro-optical system. This houses an infrared search and track system. It enables the Su-57 to passively hunt enemy aircraft by detecting their heat signatures, allowing the pilot to lock on without emitting radar waves and revealing their own position. Managing this massive influx of multispectral data requires advanced interface technology. The Su-57 utilizes a glass cockpit integrated directly with a helmet-mounted display system. Onboard artificial intelligence acts as a sensor fusion hub. It aggregates the telemetry from the X-band, L-band, and infrared sensors into a cohesive visual picture, projecting it onto the pilot's visor. They can lock onto a target off-bore sight simply by turning their head. The Su-57 functions as a networked sensor node, designed to detect and engage adversaries before they enter traditional visual range. To capitalize on that sensor advantage, the aircraft requires a propulsion system capable of extreme maneuverability and rapid positioning. Current production models rely on a pair of Saturn AL41F1 afterburning turbofans, which provide a combined 142.2 kilonewtons of thrust with afterburners engaged. These engines utilize 3D thrust vectoring control. Unlike standard fixed exhaust nozzles, the engine nozzles on the Su-57 can tilt independently in any direction. This physical articulation grants the aircraft extreme post-stall supermaneuverability, allowing the pilot to execute incredibly tight turns and complex acrobatics at very low speeds. However, fulfilling the aircraft's true fifth-generation design requires the upcoming second-stage engine, the Deadliest 30. A defining characteristic of fifth-generation air combat is supercruise, the ability to maintain supersonic flight without dumping fuel into afterburners. The Deadliest 30 engine delivers exactly this. It pushes the aircraft to sustained speeds between Mach 1.3 and 1.8 highly efficiently, massively increasing its combat radius to roughly 1,500 kilometers. This chart illustrates how that extended range supports a massive payload capacity. The propulsion system is designed to carry a heavy armament load. It carries up to 10,000 kilograms of munitions. For air-to-air engagements, it utilizes R-77M long-range active radar homing missiles, stored securely inside the main fuselage base. For surface strike missions, the bays accommodate Ka-69 stealth cruise missiles and Ka-B precision-guided bombs, ensuring lethality across multiple mission profiles. Integrating the Deadliest 30 engine is the final engineering step. It elevates the airframe's raw payload and sensor capabilities into a sustainable, long-range threat. Moving from engineering schematics to the runway, the Su-57 is built for the realities of modern deployment. It possesses a unique capability among fifth-generation fighters: rough field operation. While Western stealth fighters often require pristine runways to protect sensitive intakes and landing gear, the Su-57 integrates built-in mudguards and a ruggedized tricycle landing gear system. This allows it to launch from semi-prepared or improvised tactical airfields. Sukhoi has already tested these systems in combat. Early prototypes were deployed to Khmeimim Air Base in Syria to evaluate the sensors in a live electronic warfare environment, and the aircraft has seen active use in the conflict in Ukraine. This infographic details the Su-57E, the customized export variant. According to reports, the Algerian Air Force has signed contracts to acquire this model, marking it as the first international operator. The Su-57 functions through the integration of structural stealth, multispectral sensor dominance, and advanced thrust vectoring. To review all the schematics and specifications covered today, check the description to download the full PDF guide. Make sure to subscribe to MKN Universe for more